Are you thinking about updating your house or building a new one? How would you feel about making your home more environmentally friendly? If it is important to you, passive house design and its ability to reduce a building's energy consumption might be what you're looking for. Let me explain. Hi, I'm Jean-Michel, founder of PlanEdge, a passive house contemporary design architecture firm in Washington, D.C. I love creating modern spaces and addressing climate change. Today, we are going to explore the 4 principles of passive house design. But before that, if you don't know about the concept of passive house design, you should check out my video linked below. Alright, let's dive in, starting with a concept you may have forgotten since high school physics: thermal equilibrium. When two objects with different temperatures touch each other, they always exchange energy to reach the same temperature. A building's interior and the exterior are no exception to this rule. As a result, homes built with conventional methods require a lot of energy to battle the energy exchange and maintain a comfortable indoor temperature. Passive house is intended to reduce these energy needs by 1. Reducing energy transfers between the indoor and the outdoor as much as possible, and 2. Controlling the inevitable energy exchanges. To achieve this, passive house design can be broken down into 4 principles: thermal control, exchange control, moisture control, and radiation control. First, the most obvious principle: thermal control. Energy exchanges can happen via materials that are in contact with both the inside and the outside. Therefore, to address thermal control, passive house design prioritizes highly efficient and continuous insulation. In fact, it is the first item most people think of when mentioning passive house. Adding a thick layer of insulation materials helps reduce large energy exchanges. The type of insulation, such as the thickness, depends in part on the project's climate zone. Additionally, to achieve greater thermal control, we need to remove thermal bridges. Conventional construction overlooks details where material is both inside and outside, or insulated elements are misaligned, creating a gap in the continuous insulation layer. This results in a thermal bridge that facilitates an energy exchange. With passive house design, all those details are studied and addressed to eliminate the energy exchange. The second principle is the most complex to achieve during construction: air exchange control. Even if insulation limits energy exchanges through materials, energy leaks can still happen via air circulation in and out of a building. To reduce temperature fluctuations, passive house design focuses on creating an airtight envelope so that there are no more than 0.6 air changes per hour at high pressure. In plain English, this means that without any exhaust fan, the house should have no more than 0.6 of its air volume going in or out of the house every hour. That might seem like a lot, but a conventional house may have between 3 to 6 times its air volume coming in and out. Practically speaking, this means that during winter, a conventional home's heating system must turn on 3 to 6 times an hour to compensate for the cold air coming in. Whereas, in a passive house, it might only turn on once every 2 hours. That's a lot of energy and money saved. Creating a continuous air barrier is easy to plan on paper, but it is harder to achieve during construction. When you consider all the complex nooks, cracks, and corners that a building can have, it is one of the most complicated tasks during construction. Not all air circulation is bad though. Homes need ventilation to replace stalled air. Passive houses use a continuous ventilation system known as Energy Recovery Ventilator, or ERV. This equipment uses the same thermal equilibrium phenomenon that I discussed earlier, this time to our advantage. Specifically, because the exhaust pipe and the intake pipe touch each other, the fresh air is warmed by the heat of the exhausted stalled air in winter and cooled by the exhaust stalled air in summer. This brings the fresh air temperature closer to the desired indoor temperature with less energy.
reducing the effort for the heating and cooling system. The third principle, which is the one that surprises people the most, is moisture control.
After tackling thermal and air control, we need to address energy exchanges happening via vapor circulation. Because passive houses are more airtight, less humidity is transferred between the inside and the outside. As a result, when designing a passive house, it is important to prevent high level of humidity that may condense and harm the building.
To better regulate the humidity created inside the building, passive house design uses a continuous vapor barrier to block the airborne water from getting into the insulation, where it would condense, damage the materials, and potentially form mold. Passive house design also relies on a continuous water barrier, also known as waterproofing. It is not unique to passive house design. Nonetheless, it is crucial because it prevents water from infiltrating the construction. The ERVs I mentioned when discussing air exchange control are also important for moisture control. Depending on the house climate zone, ERVs can be equipped with a dehumidifier. It will easily adjust the humidity level. For example, in the winter, it will turn cold, dry, fresh air into warm, moist air. The opposite happens in summer when you need less humidity in your homes. The fourth one is the oldest principle in architecture, radiation control. And don't get me wrong, when I say radiation, I'm talking about the sun. It is a major source of heat that is useful in winter, but challenging in summer. One way to address its impact is to install high-performance windows with highly efficient glazing that contribute to the building's insulation barrier. An older approach, dating back centuries, is adjusting the house orientation to the sun path to control its impact. In the winter, the goal is to optimize energy gain to reduce energy needed for heating. This can be achieved by opening large windows toward the south while limiting the opening toward the north. In the summer, the goal is the opposite so that less energy is needed to cool the building. This can be achieved with overhangs and vertical louvers to block the heat from the sun. The location of trees and nearby buildings is considered when determining the correct amount of sun gain and sun protection when designing a passive house. That's it, you know all about the 4 principles. Would it help if you could learn more about passive house design? Then subscribe to the channel so you don't miss my next video where I'll explain the many benefits of living in a passive house.